Hi, welcome to Storage 204. In this session, we'll be talking about accelerating innovation with Amazon EBS. My name is Ashish Palekar, and I am the general manager of our Snapshots business. And today I'll be covering all the things that are new and exciting for our customers within the EBS space. Here's our agenda for today: a brief overview of what's Amazon EBS, and then we'll dive straight into what's new with EBS. So, kicking things off for the overview, when we think about our storage portfolio, we have offerings in Object, which is Amazon S3. We have offerings in File, which is EFS, our FSx offerings for Windows and Lustre, and then we have AWS Backup in the backup space. For today's session, what we'll be focusing on is EBS and EBS Snapshots, which is our block storage and our backup offering for block storage. So what is EBS? Think of EBS as block storage volumes as a service that is attached to EC2 instances within the same availability zone. You can create, attach, and manage these volumes through your API, the SDK, or the console. It is flexible in terms of storage and performance for dynamic workloads. Think stateful containers. We also support point-in-time snapshots, which are really backups for your volumes, and you can then manage them with tools that support automated backup and policies. On the right, the graphic shows you our SSD-backed volumes and our HDD-backed volumes, and today we are going to cover all the things that have changed in that space. So what do customers care about EBS? When we talk to customers about why they use EBS, really it boils down to high performance, up to 64,000 IOPS and 1,000 megabytes per second, and we'll talk about how that's changing. It's reliability, thinking about 5 nines of availability and between 0.001% and 0.02% AFR. They like the scalability, the ability to start with a single gigabyte and scale up to petabytes of workload dynamically, allows customers the flexibility of scaling up and scaling down as their workloads change. And underneath all this is the ease of use about creating volumes, increasing capacity, changing volume types, security in terms of encryption and turning on encryption by default, and the cost effectiveness, which also we shall cover today, going with offerings in the HDD space all the way up to the SSD space. This has been our pace of innovation and a little bit of the journey that EBS has been on. We launched in 2008 with standard magnetic and snapshots. Really, it had 100 IOPS at that time. Over time, we've increased our offerings. We launched Provision IOPS with IO1 volumes in 2012, GP2 in 2014. We launched ST1, SC1 in 2016. And then most recently, in August of 2020, we launched our IO2 volume offering. Along the way, we've also added features and capabilities. So first, in terms of performance, we added support for EBS Optimized. We added encrypted volumes in 2015. We added elastic volumes in 2017. We launched DLM in 2018, and then added a bunch of new capabilities like Fast Snapshot Restore, Direct APIs, and multi-attach over the last 2 years. And all along, we have been continuing the journey of providing more performance in terms of throughput and IOPS. And you can see that pace started with 100 IOPS, and where as of 2018, we supported up to 64,000 IOPS and 1,000 megabytes per second. So what's new? If that was the journey, how's that changing? Well, let's start with GP2. Really the most common volume type that we see customers use. It was launched in 2014. The key thing about GP2 was it is simple to use, has storage-only provisioning. You give capacity. The IOPS scale at 3 IOPS per GB, right up to 16K IOPS, and up to 250 megabytes per second in terms of throughput. And to help smaller volumes get the performance they need, GP2 had burst up to 3,000 IOPS for volumes less than 1 terabyte. And it was a low-priced SSD, really suitable for general use cases. It was used as boot volume. It is used for database workloads. It's used for transactional workloads of all kinds. And really, we see myriad workloads all on GP2. And we see customers successful with GP2. You can look at customers like Bristol Myers Squibb, Experian, Capital One, who've all built key pieces of their infrastructure using GP2. Well, customers continue to give us feedback about what they wanted to see in GP2. And so to handle those use cases, at re:Invent, we launched GP3, which is our next general purpose SSD. The key thing there is for storage prices, we dropped it by 20% compared to GP2. So GP2 was 10 cents per gigabyte month, US East 1 pricing. With GP3, the storage pricing is 8 cents per gigabyte month. The other thing that customers gave us feedback on is they really didn't want to deal with burst. And while burst worked for a lot of workloads, some customers expressed concern about, well, what happens if we don't have burst? So with GP3, we went ahead and addressed that, and now are giving customers a consistent 3,000 IOPS and 125 megabytes per second, all the way from 1 gigabyte up to 16 terabytes. And then the last thing that customers came and told us is they don't want capacity to scale with performance, because what that means is they end up having to over-provision capacity, or they end up having to have capacity, having performance that they don't end up using all the time. And so with GP3, what we're doing is giving customers the flexibility to provision IOPS and capacity. And along the way, we've increased the throughput from 250 megabytes per second, which is the current maximum on GP2, all the way to 1,000 megabytes per second, which is 4x that of GP2 on GP3. And in that sense, GP3 can now substitute for the use cases that previously needed GP2. We think that is extremely compelling for customers to migrate from GP2 to GP3 using our Elastic Volumes command. And you can migrate performance and you can migrate capability all the way to GP3. So we are excited to bring this to our customers. Our next set of volumes in the SSD family is our provision IOPS, or IO1 and IO2. The key thing with provision IOPS that we try to provide is predictable high performance. And IO1 and now IO2 has up to 1,000 megabytes per second in terms of throughput and up to 64,000 IOPS. And you can dynamically change the IOPS and IOPS and capacity separately. We launched IO2 in August of 2020, and that gave customers 100x the durability of IO1. So IO1 was 3 nines of durability to 5 nines of durability with IO2. And then with IO2, we also give customers the ability to provision 500 IOPS per GB, which is 10 times that of IO1, which provisions up to 50 IOPS per GB. Right? So customers continue to use IO2 and transition and use Elastic Volumes to migrate from IO1 to IO2. The core use cases for IO2 stay the same that they were for IO1. It is ideal for critical applications, mission-critical databases that have needs for sustained IOPS. And here's examples of customers who've taken advantage of that. So Repricer takes advantage of our high-performance SSD option, and we're able to design a storage platform which mirrors their data access patterns of their application. And because of that, they were able to reduce cost and deliver even stronger application availability. Hess is able to use provision IOPS in conjunction with instances optimized for EVS performance and deliver consistent low latency performance for servers that have very, very high I/O demand. Provision IOPS could also be configured as RAID in their cases to give their customers increased performance. We didn't stop there. At reInvent, we announced a preview of a new capability we are calling IO2 Block Express. And IO2 Block Express takes the goodness of IO2 and adds a whole lot more. Really, it is a ground-up effort that we've made, building our next-gen architecture. It delivers 4x the throughput and 4x the IOPS. So if you're keeping track, IO2 Block Express quadruples what we delivered just in August on IO2. So you can use up to 4,000 megabytes per second. You can provision up to 256,000 IOPS and 1,000 to 1 IOPS to GB ratio on a single volume. And the other thing we heard from customers is they wanted more capacity per volume. So IO2 quadruples the capacity per volume as well, allowing you to provision up to 64 terabytes per volume. And this is our first volume with sub-millisecond latency. Again, taking the use cases of IO2 and adding a whole lot more performance and adding more capacity and lower latency. This is available in preview. Customers can sign up and take advantage of what IO2 Block Express brings. And so that's the journey, right? So if you remember, we started this journey with what we did in terms of standard magnetic, then IO1, GP2. To this journey, we've now gone to 256,000 IOPS and 4,000 megabytes per second, all possible because of a ground-up architecture change on our storage side with Block Express and a networking protocol change that we partnered with our networking team and Annapurna Labs to launch our SRD offering. We didn't stop there. We also then optimized what we can do from instance to EBS. So if you think about EBS optimized performance, what that means is if you have multiple volumes attached, multiple EBS volumes attached to an instance, that is the performance from a single instance to all those EBS volumes. And some customers came to us and said, well, we'd like to do more. And especially with the launch of high performance volumes like IO2 Block Express, one of the things that we wanted to ensure was that customers would have instances that can take advantage of that high performance. And so what we've launched is, in partnership with our EC2 team, is the R5B instance, where we've quadrupled the maximum IOPS and bandwidth that is available from a single instance. So you can do up to 7,500 megabytes per second and up to 260,000 IOPS from a single R5B instance. Again, similar to IO2 Block Express, R5B takes advantage of our scalable, reliable datagram networking protocol. We call it SRD. And the key advantage of that is the improved performance, but also reduced latency outliers for our customers. R5B is ideal for I/O and throughput-heavy database use cases. So let's put the picture together. With R5B and what we are seeing from a performance standpoint, with IO2 Block Express, you can triple or quadruple the IOPS and throughput of your applications. And really, this combined offering is what we are referring to as SAN in the cloud. Those workloads that traditionally on premises would have needed SAN-like performance, we believe with R5B and with IO2 Block Express, customers can take advantage of those same capabilities in the cloud and take advantage of the elasticity and the scale that the cloud brings. Then on IO2, to help customers with higher IOPS workloads, we have a price drop. To set the baseline, on IO2, you had to pay 6.5 cents per provision IOPS month. So to help reduce the cost, what we've done is from 32,000 IOPS to 32,001 IOPS to 64,000. We've taken a 20% lower IOPS price to 4.6 cents. And then above 64,000, we've dropped that IOPS price even further by 20% to give you up to 3.2 cents per IOPS month. So in other words, with IO2 and IO2 Block Express, we're making it even more convenient and even more affordable for customers to have high-performance workloads on IO2. The next on IO2 at re:Invent, what we also launched is multi-attach. So multi-attach is the capability where a single EBS volume can connect to multiple instances. We had previously, in 2020, in February, launched this on IO1. We are happy to bring that same capability now to IO2. So with IO2, you can now attach up to 16 instances to a volume. So you can now take advantage of the 5 nines of durability and take advantage of the clustered EC2 performance. A customer example here is Netflix saw a 4x improvement in the time to warm up their EV cache, and further were able to limit the network impact to clients by using multi-attach and EBS optimized networks. This is ideal for cluster-aware shared storage applications such as GFS2, which are able to manage distributed access to shared storage. So we talked about our SSD family. Let's turn our attention to our HDD volume family. So our HDD volume family consists of ST1, which is a throughput optimized HDD, and SC1, cold HDD. The throughput optimized HDD gives you up to 500 megabytes per second in terms of throughput, and SC1 gives you up to 250 megabytes per second in terms of throughput. Both of these are optimized for large block, think 1 megabyte, 2 megabyte sequential I/O, and cold HDD was already the lowest cost EBS volume type. So you can see customers like Geodata and X2X have been using SC1 volumes as a way to keep their costs low. In the Geodata case, Geodata was able to reduce its storage costs by more than 70% and overall AWS monthly costs by 40% by using SC1 as a part of their tiering strategy for their volumes. And again, their words, if they had to build something like this on premises, that would be much more expensive and complex, right? X2X, similar experience for them. They have helped, SC1 volumes have helped reduce the cost, and they've been able to build a rated environment that gives them the performance that they need. We've taken the next step with our SC1 volumes by dropping the price on our SC1 volumes by 40%. So the price before was 2.5 cents, and now with SC1 volumes, you'll pay 1.5 cents, which is a 40% reduction on cold HDD. So what was economical before has become even more economical from a capacity standpoint. And we didn't stop there. The minimum volume size was 500 GB. And some customers came and said, well, I have workloads that don't exactly need 500 GB. And so we have gone ahead and reduced the minimum size of volumes to 125 GB, which is a 75% reduction. So now, if you have customers and if you have workloads that were using 500 GB of SC1 volumes before and only needed 125, with the combination of these two capabilities, which is the 40% price reduction and the reduction in minimum size, you can save up to 85% for your log processing and nearline storage workloads. This is exciting because it makes ST1, SC1 available to a whole new class of workloads and use cases. It's pretty excited to see what customers can do with it. One of the things that customers came and said is, as EBS keeps on evolving and keeps on changing, it becomes hard for them to keep track of all the changes and to understand what things they should be optimizing in order to take advantage of this feature. So to support this, we've been working with our Compute Optimizer team and have now started to bring improvements into Compute Optimizer. So earlier in 2020, we launched capabilities that allowed Compute Optimizer to recommend EBS optimized instances. And so depending on what you're using, Compute Optimizer will give you a recommendation to use the right instance type for your performance needs. Now, at reInvent, what we've launched is giving customers the ability to optimize their EBS performance. So if you have an IO1, IO2 volume, you can optimize your provision IOPS setting. With GP2, GP3, you can optimize the size of GP2 volumes to meet your performance needs. And with GP3, you can optimize IOPS and throughput recommendations. So this is taking all the learnings that AWS has had with performance workloads, taking machine learning to your workloads, and then bringing recommendations that can help you optimize performance, save cost, and essentially eliminate manual optimization. And these changes are available at no additional charge. So moving our attention to snapshots. Snapshots, as we discussed earlier, launched in 2008, really are cost-effective incremental backups that charge for changes that are made between snapshots. They're simple to use, flexible. You can use snapshots to copy volumes across or to move data across availability zones, to move data across accounts, across regions, and also to create Amazon machine images or armies. Together with that, we have another capability called Fast Snapshot Restore. This we launched at reInvent in 2019. It gives you immediate full performance volumes created from FSR-enabled snapshots. So you can take a snapshot, enable it for Fast Snapshot Restore within an AZ, and from there, once it's fully optimized, you can get immediate full performance volumes that are created from that FSR-enabled snapshot. You get predictable performance without the need to initialize your data in an EBS volumes. This is ideal if you have pre-planned use cases such as booting for custom armies, or if you need to restore volumes in your test DR or DR scenarios. This is ideal for those use cases. An example of this, this flexibility of all these offerings is what Experian is doing. With Experian, what Experian found is that EBS allows them to add more data and quickly change the volume of data. And that's a huge game changer as they think of how they react to market conditions. And that performance, scale, and elasticity is exactly the value proposition that we see customers taking advantage of with EBS. So as we now look at the snapshot space, with FSR for shared snapshots, we've now enabled customers to start FSR on snapshots that are not in their account. And so what this means is, if you have an army that you need to share across accounts, you don't need to copy it in order to have volumes boot from it quickly. You can share it, enable FSR, and then you're off to the races. We've also been expanding our FSR availability in commercial in all our regions. At this point, it's available in all commercial, GovCloud, and China regions. Then we talk about, let's talk about Data Lifecycle Manager, or DLM. Just as a quick recap, DLM was launched in 2019, and its goal was to be simple to define and manage backup and retention schedules. Right? It's a simple way to get policy-based management of snapshots. And it uses tag-based policies, and so you can apply it to one or many EBS volumes. We've seen a lot of customer adoption to create simple policies and manage backup and retention schedules. Customers came to us and said, DLM manages snapshots, love what DLM is doing for snapshots, but can you go ahead and manage armies? And so that's exactly what we've done. In partnership with the Army team, we've now expanded DLM to create and manage EBS-backed armies. In addition, we now support granular scheduling using cron expressions, and we also allow multiple schedules in a single policy, which means that customers can now schedule dailies for a week, weeklies for a month, monthly for a year, and have that be part of a single policy, helping customers optimize costs and costs of snapshots, as well as of EBS-backed armies. To further expand what customers can do with snapshots, in 2019, we launched EBS Direct APIs. And the goal of Direct APIs was really to give customers the access to EBS data, to create an EBS volume. And so what we did was we created read and write APIs that allow customers to read the data, to get the delta set between two snapshots, or write a completely new snapshot. And we were able to reduce backup times for our partners by doing this. And Direct APIs also help partners achieve business continuity at a lower cost. In addition, one of the other things that we are seeing is customers are now using these write APIs to write snapshots directly, so as to get data protection for on-premises data or data in other forms of block storage. We think of Direct APIs as helping customers optimize recovery times and allowing hybrid deployments. So we've talked about AWS cloud. We've talked about the cloud and what we are doing with AWS regions. But we also know that customers are on premises, in their metro centers, and on 5G networks. And we see that customers are expanding to IoT and rugged edge. And it's super important that we bring the capabilities of AWS in those spaces. So that is where Outpost comes in. Outpost really was bringing the core capability of Outpost was to bring the AWS cloud to your data center. And as customers deployed it, initially, what we had is Outpost with EBS running on it with EC2. And then when customers needed to take snapshots, one of the things that they had to do was take that storage and put it into the region. So we had S3 in the region, and then EBS snapshots within the region. Some customers came and said, well, I have data residency needs, and those needs imply that I have to keep the snapshots and my S3 data within my corporate data center. And so earlier this year, we launched EBS Local Snapshots on Outpost. And so now you can now use S3 on Outpost and EBS Local Snapshots on Outpost and keep your data completely within your corporate data center. So pretty excited to expand the Outpost use cases for customers who want to meet their data residency requirements. And so Outpost, EBS Local Snapshots on Outpost provides all the capabilities that you're used to with snapshots in the region. You can store snapshots of data, boot volume, and EBS-backed armies on Amazon S3 in AWS Outpost. You can create point-in-time incremental snapshots of block storage. You can copy snapshots or armies to AWS Outpost, boot instances, hydrate volumes from it, and all local snapshots are encrypted by default. You can go to our website to learn more, and you can also manage this using DLM. And so, taking that picture further, we now see that we can bring EBS as well as local snapshots to an outpost near you. So, what have we learned today? How to think about EBS in continuing to lower costs for our customers. We saw that with the IO2 pricing change. We saw that with the SC1 price drop. We also saw that with the increase with GP3 and providing a lower price point for capacity there. We're continuing to increase the level of performance and reliability that we offer. We started with IO2, bringing IO2 Block Express, all the things that we're doing with R5B, providing you more and more flexible tools to scale and manage. Think about the things that we talked about with Compute Optimizer or Data Lifecycle Manager. We're continuing to make it simple to use and manage securely, and continuing to expand the use cases that we serve for you. Please visit our training and search sites. You can learn about storage. There are free digital courses. You can go into classroom trainings. You can also ramp up with labs, with white papers online. Please visit, take advantage of this, and learn about all our storage offerings. With that, thank you so much for taking the time to attend this session. We would absolutely appreciate you taking the survey and giving us feedback on how this session has been. Thank you so much for your time today.